Welcome back, noobs and pros. I am Funny Chidela, and you are listening to Kubernetes Notes. Some of you might be expecting an episode on another topic this week, but more on that towards the end of the episode. I came across an interesting article that was published in March of 2023, if I'm not mistaken, about how a team reduced the infrastructure cost for one of their services by 90% by using the monolithic architecture. We exclusively talk about microservice architecture, seeing that this podcast is about Kubernetes. Just because something works most of the time doesn't mean it would work all the time. Prime Video's Video Quality Analysis or VQA team has an audio-video quality inspection tool which was not built for scale, leading to high infrastructure costs while running the tool at scale. The initial version had distributed components orchestrated by AWS step functions or Lambda. The most expensive operations were the orchestration workflow and the storage cost for the intermediate data passed between different components. This led to the team consolidating the three components into a single process with the data kept inside the process memory, reducing the data transfer cost and simplifying the orchestration logic. Before going further, let's briefly look at the tool's initial architecture. The tool has three components. The media converter converts input audio-video streams into frames or audio buffers, which is then sent to the detectors. Defect detectors analyze the frames and the audio buffers in real time and send real-time notifications when a defect is detected. Finally, the orchestration component controlling the service flow. These components were built using AWS step functions, which in theory would allow each component to scale independently. However, the tool was too expensive to be acceptable at scale. Orchestration management was the main bottleneck, hitting the account limits very quickly. The second problem was the S3 bucket cost to store and pass the video frames and audio buffers, entering the monolithic solution. The team noticed that the distributed solution wasn't beneficial for their use case and packed the components into a single process, eliminating the need for the S3 bucket for video frame storage. The team could reuse much of the existing component code since the architecture was the same at a high level. Defect detectors were cloned with different subset of detectors to account for single instance limits. The episode continues after this short message.
If you like this episode, please consider following us wherever you hear your podcasts.
The episode will continue after this short message. If you like our work and would like to support us, you can visit buymeacoffee.com/Chintu. That is buymeacoffee.com/CHINTU. Now, back to the episode. Now let's look at the key takeaways. I found this article very interesting. Just because you hear about the advantage of microservice architecture doesn't mean you shouldn't use monolithic architecture wherever necessary. The initial three-component architecture was great for setting up the service quickly but unsuitable for scale. The new architecture utilizes EC2 with the compute savings plan and ECS to reduce costs. A tool or service is a combination of decisions, some obvious and some not. The best thing about designing a new service is that we make decisions on a case-by-case basis and build and improve the architecture over time. The link for the article is added to the episode's description. Thank you very much for listening to us. I'll be back with the next episode on stateful sets. If you have feedback, please write to us at cubenotes@cent.com. That is KUBE, B for Boston, notes@cent.com, or message us. We are at CubeNotes on Instagram and Kubernetes Notes Podcast on LinkedIn. I am Fanishi Della, and you were listening to Kubernetes Notes.